First, let's try to define a regular expression, or regex as it is usually abbreviated. A regular expression is represented by a special syntax that helps you find and match a pattern inside a string. Let me give you a very basic example. Let's say you have the following string. Okay. Now what if you want to find the programming language in this string that starts with a capital P and has 4 letters? Or the ones starting with the substring Java, regardless of J being uppercase or lowercase. Or maybe you want the last 4 characters before the 3-digit over here. For all those cases and many more, you will use regular expressions. In this lecture and the next one, we will talk about 4 functions that Python provides for dealing with regular expressions and text pattern matching. Another thing you should know is that all operations related to regular expressions are provided by the re built-in module. So whenever you want to use regular expressions, you should first import this module using import re, and then prepend any function you use with the re and a dot. Now let's start discussing the first function, which is match. The match function searches the pattern you provide as the first argument in the string you enter as the second argument, but only at the beginning of that string. The general syntax for this function is the following. Let's say we type in a equals re.match, and in between parentheses, the first argument is the pattern you want to match, so let's say pattern. Then you have the string in which the matching is done, and then some optional flags. And that's it. A, in this case, is called the match object if the pattern is found in the string. Otherwise, A will be none if the pattern cannot be matched inside the string. Now let's return to our string mystr and use the match function to see if the characters y, o, and u are indeed at the beginning of the string. So we imported the re module. Now let's do a equals re.match. First you type in the pattern, in our case y, o, and u, and then the variable in which the string is stored, so mystr. Okay, let's check a. So you see that a is a match object, because Python has found the string given as a pattern, you, at the beginning of the mystr string. Now, if you would try to match a random string to the beginning of mystr, you should get back none. So, don't trust me, let's verify this. Let's say ABC. Let's check A. Okay, nothing is returned. Let's do a type on A. So indeed A is of type non-type. Okay, now let's redefine A as it was before, so it would return a match object again. Okay. You can have the entire match returned by using the group method on the match object. So let's see this. Let's do an a.group, open and close parentheses, and we get u. As I said, Python returns the match it found in the string according to the pattern we provided. In this case, the pattern was the string itself, y, o, and u. Now let me give you an example that uses an optional flag. Let's redefine A and add a flag that tells Python to ignore the case of the matched letters. So let's do an y, o, and u with the lowercase y on string mystr and re dot capital I. Let's see A. Okay, we have a match object. Let's do an a dot group and we see u returned. Okay, this time we provided the string u in all lowercase, although in mystr we have u written with a capital Y. Let's see. Okay. The match function still returned a valid object because we specified the re.I optional flag for ignore case as the third argument of the function. There are other flags as well. I just wanted to give you an example for now because I find this particular flag very useful. Now, for example, let's say we don't have the string you at the beginning of the string. Let's see my str again. So let's say we don't have yo and u at the beginning of the string. Instead, we have it somewhere in the middle. So let's change my str. Let's copy and paste this. Okay, let's go over here. Let's delete this and let's say we have u here. Okay. Now let's do the same match as we did before. So we are trying to match you at the beginning of string mystr, ignoring the case. Let's see a. Okay, this time nothing is returned. Let's do a type on a. Okay, this time the match function returns none because the pattern we are searching for is not located at the beginning of the string. It is located in the middle of our string. Now, to search for a pattern throughout the entire string, we will use the search function. This function is used more frequently than the match function, and we will use it in one of our applications in the second part of the course. Actually, we are going to use about 99% of the concepts in this course within those 5 applications. Okay, we will also start using regular expressions, specific syntax, rather than searching for an explicit substring inside a larger string. The syntax for the search function is similar to the syntax for the match function. Let's see it. Let's use the same name for the match object. So a equals re.search. First you have the pattern as the first argument. Then you have the string in which you are doing the search. And finally the optional flags. So you can see that the syntax is very similar with the match syntax. Okay, let's define another string now. We will use an arp entry from the arp table of a switch. I have it saved right here. Let's do a copy and paste to save some time. Okay, let's see the string. Okay, now like the match function, search will return a match object if the pattern is found in the string, and none if nothing is found. It's time to see the search function in action. Let me write this first and then we will study the syntax. Okay, let's assign this to A. Okay, now, what language is this, you may ask? Well, this is the syntax of a regular expression. Let's take this one bit at a time. First, you can see that the arguments of the search function are, first, the pattern to be matched, and second, the variable which holds the string in which to search for a pattern match. No optional flags this time. Another thing here is the lowercase r, right here, before the pattern. This means that the pattern should be treated like a raw string. A raw string is useful to avoid conflicts between the way Python recognizes an escape sequence and the way the RE module does it. We will talk about escape sequences soon. Now let's dissect the syntax for the pattern. First, notice the parentheses surrounding some of the symbols. Any pair of parentheses matches the regular expression in between them and, as defined by Python's official documentation, indicates the start and the end of a group. So we have a group here, another group here, a third group here, and this is the last group in our pattern. If a match is found for the pattern inside parentheses, so let's say for this group, then the contents of that group can be extracted with the group method applied to the match object. So you can use a.group to extract the matched pattern inside parentheses. Now inside the first pair of parentheses, we have a dot, a plus sign, and a question mark. Each symbol has a meaning and matches something in particular. In regular expression syntax, a dot represents any character, except a new line character. The plus sign means that the previous expression, which in our case is just a dot, may repeat one or more times. So this group will look for at least one character. Any character, doesn't matter if it is a letter, a number, a space, or a punctuation mark, or whatever. Now, remember one thing. The plus sign, which means one or more characters, or one or more repetitions of the expression before it, and the asterisk, so plus, which means one or more repetitions, and the asterisk, which means zero or more repetitions of the expression before it, are both greedy, meaning they try to match as much text as possible. Let me show you what I mean. Let's see what does Python match for the first group of parentheses, having the question mark as it is. To see this, we'll use the group function with 1 as argument, meaning the first group in the pattern. So, let's see this. Let's do a dot group of 1. Okay. Now let's remove the question mark from the pattern and see what the search function returns. So let's go ahead and delete the question mark and a dot group of 1. Okay, notice the difference. In the second case, the plus sign was so greedy that it has included the spaces following it in the matching group. But when we had the question mark in the first case, the match was made in a minimal fashion, matching as few characters as possible. Now we've seen the role of the question mark in regular expressions, so the choice of matching in a greedy or minimal fashion is purely yours. One more thing on this greedy behavior of the plus and asterisk signs. Up to which point is the plus sign greedy in our example? Well, by looking at the ARP entry format, we see that after the IP address there are 6 spaces, then the 0 digit, and then the rest of the line. So here we have 1, 2, 3, 4, 5, and 6. 6 spaces. Okay. That's why inside the regular expression pattern, I typed in a space after the closing parenthesis, so this space over here. My intention was to tell Python that I want to match a group, this group, until a space is encountered. When the question mark was inside the parentheses, Python understood that it should match any character one or more times until the first space character occurs, so this one over here. This was made in a non-greedy way. That's why the matching stopped right before the first space, and we just got the IP address. When I didn't use the question mark, Python understood that it should match any character one or more times as greedy as possible until the last space character is encountered. That's why the matching stopped right before the last space character, so this one over here. Since the matching has been done in a greedy way this time, we got the IP address followed by 5 space characters. So let's count 1, 2, 3, 4, 5. This is because Python stopped matching right before the 6th space, so the last one again over here. Notice that for a correct match result, you should always be careful at both the greedy behavior and the characters following the group, because they act as limits or borders for the pattern you want to match. Now moving beyond the first group, we have the space we talked about, followed by a plus sign. This means that looking at the ARP entry format over here, we are expecting one or more space characters after the IP address. We know that there are actually 6 spaces there, but it is safer to use one space in the regular expression and a plus sign for future compatibility. Maybe you use this regular expression in an automation suite, and the output of showIP ARP may change and have only 5 spaces there at some point in the future. You don't want to have failures into your scripts caused by a fixed number of spaces. Now let's look at the second group. We have a \d there. This is called a special sequence in Python, and it means any decimal digit, so anything from 0 to 9. Python will expect a single digit here. Let's verify this with the group method. So let's do an a.group of 2, because this is the second group, the second pair of parentheses. Okay, so we got 0 as expected. This is the digit we were referring to. Next, we have another sequence of space characters. Let's see it over here. Up to the MAC address. I'm talking about the characters over here. After this, we have a group, the third group, similar to the first one we previously discussed at large. Now let's say we want this group, which would be group number 3, to match a substring consisting of both the MAC address and the VLAN number over here in the ARP entry. And of course the space between them implicitly. For this we use the same dot plus question mark syntax, but we should also specify the limit up to which to consider this group. So the first character or sequence of characters at which Python should stop matching the group. Of course, we could use the same syntax as before with the single space character and the plus sign, but that wouldn't be fun, right? Instead, we can use something even more interesting. First, another special sequence, \s, which matches any whitespace character, whether it is a space, a tab, or a new line character. Secondly, I used a number followed by a comma in between curly braces. This means Python should expect 2 or more occurrences of the regular expression preceding the curly braces, a whitespace in our case, from the \s. Not typing the comma inside the curly braces, I'm talking about the comma over here, would tell Python that it should expect exactly 2 repetitions of the previous regular expression, so only 2 whitespaces. Now, if we would match just a single repetition of a whitespace here, the matching would stop at that one space between the MAC address and the VLAN number, or the VLAN word to be more precise. Instead, by specifying 2 or more whitespaces, Python will know to stop the matching after the VLAN number over here, because that's where a lot of spaces reside. This space is right here. Finally, the \w special sequence followed by an asterisk matches 0 or more occurrences of any word character, meaning letters A to Z and also capital A to capital Z, numbers 0 through 9, and the underscore character. Now it's time to check our groups in the pattern. So let's do a.group of 1. Okay, we have the IP address followed by those 5 spaces. By the way, let's try and fix this. Let's add a question mark for a non-greedy behavior. Now let's see a.group of 1. Okay, the IP address. A.group of 2 will match the digit because this is the second group, so 0. A.group of 3, as we wanted, matches both the MAC address and the VLAN number. And finally, a.group of 4 will match the single word character, a letter, at the end of the string. Great, this is exactly what we wanted. Also, remember that a.group without any arguments and a.group of 0 both return the same thing, the entire string. Let's verify this. Let's do an a.group. Okay, so this is the entire string. A.group of 0, and also we got the entire string back. Another method to use is the groups method, which returns all matches found in a given string in the form of a tuple, where each match is an element of that tuple. So let's see this, a.groups, without any arguments, indeed returns a tuple with all the patterns we matched inside our string. Cool. I think this video is long enough. In the next one, we'll discuss the last 2 regular expression functions.